Okay, so let's continue to talk about our properties of these functions of real numbers. This time, another important aspect is the idea of having functions being even or odd. If we have functions like y equals sine of t or y equals cosine of t, we might be interested in determining whether or not that function is even or odd. Now, don't forget that the way that it was defined is that we said we had a function that was even if substituting in a negative value for the variable was exactly equal to just not having a negative there at all in the variable, right? So f of negative t equals f of t. And we said that we had a function that was odd if substituting in a negative value for t was the equivalent of taking the negative of the entire function itself. So what could we say about a function like f of t equals sine of t? Is it even or is it odd? Well, for an even function, again, let's define this. We're saying that our function right here of t is, let's see, if it's cosine, right? We're talking about x, right? Cosine was the one that had the x value, cosine of t. And sine was what happened when we took the y value here in our coordinate point setup, right? So we might be interested in saying, okay, what's going to happen with sine of t for this first one? Is it even or odd? Well, if we put in a positive amount of rotation and compare what happens when we have a negative amount of rotation, but the same amount overall, what happens to our coordinates here? Sorry, we should make that cosine of negative t right there. And our y value is going to be the sine of negative t there. Well, this is going to be very helpful for us to know, because if we're saying, well, f of t equals sine of t, f of t is equal to sine of t here and then down here. We know that the y-coordinate down here in this location is negative, and the y-coordinate coordinate here is equal to positive. So f of negative t is the sine of negative t, but in the negative quadrant, it will be the negative of what we had in the first quadrant. So in other words, this is an odd function. Let's look at cosine of t. What happens to it? Well, cosine of t, if we put in a negative value there and compare it to the value that we get up here, right? Both of these have positive x values associated with them. So in this case, we're going to say that, well, that's the same thing as cosine of positive t. And what that indicates to us is that our cosine function has to be even. Now, we could go through and take ratios of these things, but it might be helpful for us to come back and talk about this. For right now, I could tell you that sine of t and cosine of t, odd versus even right here. It's very easy to get cosecant of t and secant of t if we recognize that, well, okay, the cosecant function is equal to 1 over our y-coordinate, and right here our y-coordinates change from positive to negative, so that makes cosecant of t an odd function. The cosecant of negative t would be exactly the same as the negative of the cosecant of positive t. Secant is an even function. And in this particular case, that would mean that if we took the secant of a negative angle, it would be the same as taking the secant of its positive counterpart. And then finally, for tangent, I'm just going to state these outright, and I'm going to come back and prove them later. But for tangent and cotangent, both of these are odd. Right? So we'll come back and illustrate these two here in a little bit. But let's take a look at this. G of x equals x squared minus secant x. Is that even, odd, or neither? Well, our test, remember, was that if it's an even function or an odd function, we substitute in negative x and see what happens. Well, substituting in negative x means take the square of negative x and then subtract from that the secant of negative x. Well, by our definitions above, this is, let's see, negative x squared is negative x times negative x, so that's positive x squared. And secant of negative x is equal to secant of x. And so what we've just established right here is that since g of negative x is equal to g of x, we would conclude that g of x is an even function. Thus, we've answered the question. All right, more to come.